Alright, so here's an interesting one. They're saying that if f and g are functions such that the limit of g of x is equal to some limit as x approaches c, and also we have another limit of f of x, um, and this limit is actually um, the function of the limit of this one right here as x approaches L. So this means I have a function that gives me a limit L as x approaches C, and that use the same L, as a C value for another function, and it happens to be a function where I plug in L. Then, if I want to use this lim of this function, but instead of using this x right here, I plug in this function. And instead of using this limit, I use c as x approaches c. So I bring in c, and I bring in the function definition right here. So that's going to give me this same thing. Alright. So think of if I'm using the x as the reference point, and that happens to be the limit of this function, then I can use this function as an input to this function, as a composite function, and I can use this c as my reference point, and the result is going to be the same thing as this one. So let's do a couple of examples. Let's say I have on this side, I have limit of x squared plus 4 as x approaches 0. So this is going to be 0 squared plus 4, so that's going to be obviously 4. And remember, the condition is that if I now approach this value 4, and I'm looking for a limit of another function, and this function happens to be, well, we don't put f, you actually just put the definition, rad x, and this happens to be equals square root of 4 equals 2. So if we use this limit right here as my c value for this function, then that means I can do this. I can plug in this function definition inside here instead of the x, and I can use this now as my c point for this. So this means I can do this. Lim of this radical, but instead of the x, I put this whole thing in here. X squared plus 4 as x approaches now this value, 0. Then I know it's going to be the same thing as this one. It's going to be a 2. And if you use a direct substitution, yeah, it works. So 0 squared plus 4, rad of 4 is 2. And so let's do another one. So now on this side, I have, this is going to be a little bit more complex. If I have a limit of this function, 2x squared minus 10, as x approaches 3, so this is going to be 2 times 9 minus 10, that's going to be 18 minus 10 equals 8. And it so happens that I use this limit here as my c value for this function. As x approaches 8 now, I have a limit of another function, which is cubic root of x, and this happens to give me, by direct substitution, equals 2. So this all means that I can bring in this one right here, and I can bring this one right here, and it'll give me the same thing. So that means I can have a lim of okay, so I bring in the function definition from the function on the left, and I bring in the 3 here. And I know that my result is going to be the same thing as that one. That's the limit of a composite function. Kind of a tricky. Maybe you don't know why you would use this, but just learn that. You have two functions, and the c value for the second function is actually the limit from the first function, and if you have that, then that means you can substitute. Instead of x, you put this function definition inside there, and instead of this c value, put this c value, and then it will give you the same value, same thing here. Thank you for watching. That was example 4.